Welcome to the GraphGeeks podcast, where we explore all of the fascinating aspects of relationships and the technologies that help us manage connected data. I'm your host, Amy Hodler, and today we're going to be diving into a topic that sparks a lot of debate and curiosity in the tech community: RDF versus property graphs. So we know graphs are changing the way we model, store, and kind of query very complex data. But when it comes to choosing the right type of graph model, the decisions often boil down to two major contenders: resource description framework, RDF, and property graphs. Now, each have their unique strengths and challenges. So I feel very lucky that we have two amazing guests with experiences in both approaches to kind of help us shed light and how they're different and how they're also similar. So first, let me introduce Dave Bechberger, who is known for his expertise in distributed data architecture and graph databases. Dave has over 20 years experience and is the co-author of the Manning book, Graph Databases in Action, and also a Tinkerpop contributor. Dave also happens to have, if you haven't met Dave yet, has a very infectious laugh. So just warning on potential chuckles as we go through this. Next, we have my friend and past colleague, Jesús Barrasa, who has decades of experience implementing graph solutions and also a PhD in knowledge representation, so kind of understands both the commercial and the academic world. Jesús is also co-author of the book, the O'Reilly book, Building Knowledge Graphs, and is a co-host of the Going Meta Live webcast. So welcome, Dave and Jesús. Let's get started with the basics. So Jesús, can you briefly explain what RDF and property graphs are all about, especially for listeners that might be new to graphs?
Sure. Of course, yeah, and I think you did a great job in the introduction, Amy. So property graphs and RDF are the two main, I would say, approaches to managing data as connected data as a graph, right? In the mathematical sense, right? So vertices and edges. So, and like a data management approach will come typically with a model. There's a model that defines RDF. There's a model that defines the property graph, and with the data manipulation language, right? So if you're going to be, managing data, you probably have a query language, a scripting language that interacts with your data, and that will be implemented by specialized database management systems, right? And that basically defines a stack. In the RDF side, you will have what's traditionally been called triple stores. Have gone over different names over time, but basically it's triple stores, and the query manipulation language is Sparkle. And on the property graph side, typically we've called those graph databases. And in order to use the latest kind of arrival, let's call the universal query language will be GQL for the property graph databases. So I suppose we can go into a lot more detail how they're similar, how they're different, but I would say these are the two main approaches that I would say that they have differences, but the point in common is that they both have the same underlying abstraction. So they put the focus on the structural features and data, how things are connected, how things are related to each other, in order to be able to enable this type of structural analysis as well as the traditional, relational, if you want, data management.
So Jesús, you threw out some terminology there that I maybe either you or Dave can help define. First off, triple stores. So those of us who are familiar with RDF are familiar with that term, but I don't know if you can kind of explain to maybe a more novice listener, like, what is a triple store?
Sure. Yeah. No, and I suppose before we get into that, I mean the main difference between the two, because that's what will take us into the triples, is how do we represent data in the RDF space and in the property graph space. So let's think that the building blocks on the property graph side are the notion of nodes and relationships, right? And a node is equivalent to an object in object-oriented programming. An object is kind of a rich object that has internal structure, a collection of properties, and relationships are kind of similar. They connect to nodes, but they also have their own internal structure in the form of properties, right? Now, at a different level of abstraction, we have the RDF graphs that represents the world in terms of statements. And this is what we call triples, right? So if you take what we used to call a node in the property graph space, and we kind of decompose it in individual statements, each one of those statements is what we call a triple. And if you think of it in simple terms, a triple is a column with stored in a column with in a table with 3 columns, right? So that's what we call a triple: subject, predicate, object often. But if you think of triples as the minimum atom of information, when you chain triples, they form a graph, right? So if the subject of a triple is the object of another one, then you have some chaining that ultimately form graphs. So that's, the kind of building block in the RDF side of things, and stores that are specialized in managing, manipulating these type of data structures are called triple stores. But, I'll hand it over to Dave, because he probably wants to add something to that. I think that's...
I think that's a very, very good way to kind of explain it. I also sort of think of it as there's kind of two sides of the same coin. When I think about, if you want to, but when I think about graph databases, I tend to come at it from the people that are used to working with tabular data and used to working with relational data, because I think that's Excel is kind of the way that most people seem to think about their data. And when I think about property graphs, you can kind of think of like an object in a property graph as an object in object-oriented programming, or like a row in an a column of Excel. And when I think about triples, I think it's a pivot of that, where basically each of your, it's essentially a 3-column Excel table where each of those columns represents a specific part of that data. And to build out a more robust object, you add additional rows instead of adding additional columns to represent additional properties. So I kind of think of the two as like a pivot of one another, depending on which way you're translating your data.
So I was going to ask this later, but I'm going to bring it up anyhow, since we're kind of setting some grounding, for the listeners. There's some other terminology you hear a lot. The other one in general, you hear a lot about semantics, and then the other one is ontology. Explain what semantics are and how you explain what ontologies are.
Yeah, and actually that's I would say that this is sort of an extension. I said that the property graph and the RDF, they define kind of a stack, right? And it's probably worth mentioning that the RDF, if we look at history a little bit, it kind of comes from the last years of last century, right? With the vision of the semantic web came up, and that's where the connection with semantics comes. So the idea is that was back then that there's lots of information in the web, but it's presented in a way that's meant to be consumed by humans through a browser. So you go read it and you make sense of it, but as a human you have to understand it. Now, what if we put some meaning associated to that data, so that not only humans but maybe agents, as they call it back, some software could interpret it or do some smart stuff with that data? Now, the idea was, let's inject some information about the meaning of that data so that these agents can do something clever about it. So to your point, Amy, so semantics is meaning, right? And it's true that the moment we store data in a relational database, in an Excel spreadsheet, doesn't matter really. So some of the meaning of it might be lost, in the sense that someone who goes and consumes it, may or may not understand what the author put into that model, right? So in the RDF stack, there's this idea of, okay, let's try to add and attach to the data some description of the meaning of that data. And I would say that one of the standards way of doing it is what's called ontologies. So ontology is a explicit description of the meaning of your data, which in the simplest term, it can be a schema, right? It's just like, these are the types of entities in my graph database. That's how they relate to each other, and that can be already kind of a first semantic layer on top of my data that describes what it means. It can get a bit more sophisticated and more complex, but that's in essence the idea, right? Let's put something associated to our data so that some other software can do clever things about it. I mean, I don't know. Does it make sense as a starting point, Dave? You want to add something to it?
No, I mean, I think that makes sense. I also just like to think about it even in kind of some more simplistic terms where like semantics really comes down to what is the behavior and meaning of this data? How would I expect it to work? Where is it coming from? What does it, it comes from this location. What was the context and meaning at that specific point? And I think we talk a lot about semantics when we come here, but I think it's also one of those challenging things when people come to it is like, oh, I have to learn this entire new thing. It's like, I mean, semantics and ontologies are really just behaviors and schema in my mind. Like there are some slight differences, but in general, the way I've seen most people apply them is it really comes down to what is the context and behavior of this data? What is the schema and structure of that data on top of it? So I kind of like to, I think those terminologies tend to make it a bit more approachable for people coming from the outside. Because when I hear semantics and ontology versus behaviors and schema, like one of those to me is just, I think, a little more approachable from a naive person's perspective. But interested to hear what you guys think.
Yeah, no, I think that's a nice way to look at it, Dave. In particular, a lot of times I feel like we are splitting hairs between, theory, in a very objective standpoint versus data models versus solution implementation versus, how do people just commonly talk about and use these terms. And so I think as we discuss, we're going to dive into more detail, but just maybe for listeners to think about, some of these really are just very nuanced differences. And sometimes I think, maybe as practitioners, we make more out of the differences than are actually there. So Dave, if you don't mind talking just a little bit about standards, because I think we're kind of moving a little in that direction. RDF has a lot of standards like RDF schema and OWL. Can you talk a little bit about how these standards benefit or hamper users and what property graphs also can offer in comparable standards?
I mean, I think it's a great segue there, and I think it's one of those areas that I find kind of very interesting because in the end, when I think about pretty much any application, but the graph applications in specific, I almost think of it as like the network layer diagram where you have all these different layers that build on top of one another in order to give you additional functionality, and different applications need to run at different, with different sets of those layers in order to kind of make it work. At the very kind of base there is, in the case of a graph database, it would be the actual data structure. So you would have something like in a property graph, you would have that kind of, what Jesus was describing as far as you have, essentially I think of it as maps of data where you have attributes associated with objects. Those objects can kind of be built up into nodes and edges. In the RDF side, you kind of have a that's been very standardized across the triples pattern or the quads pattern if you want to add a kind of a named graph pattern in there as well. And then you build on top of that, you have things like constraints. Or I should actually first conceive in schema, which is basically how do you, property graphs, for example, are often described as schemaless. I personally don't like that term because if you have data, you have schema. It's just whether your schema is implicit or explicitly stated. There's no such thing as unstructured data. That would just be random. There's always some level of structure to that data. So in the case of a property graph, there's a lot of, from a standards perspective, there's some work going on with GQL as far as like PG, like the property graph schema language, but it's not, quite official there yet. But in general, most databases have implemented their own sort of schema language on top of that basic structure, whereas RDF has several different ways that are standardized across databases in order to be able to do that. Same sort of thing when you kind of go up to the next level of like constraints and being able to do that and be able to add those on top of schema. Property graph databases, they tend to either be non-existent in certain databases or very implementer-specific versions, whereas the RDF in general has much wider range of schemas across that. You can move up to additional levels of things like inference and link prediction, those sorts of things. And I would say generally, property graph has a bit more of a, call it maybe the Wild West there, as far as everybody sort of implements their own things or leaves it to the application. RDF tends to have a lot more standardized things across it. I think there's advantages and disadvantages to both, because one of the things you get with standards is also a lot of rigid structure, which is a double-edged sword. It's good to have rigid structure, but sometimes it hampers the flexibility needed by certain applications in order to be able to do things. But kind of maybe toss us over to Jesús or Amy and see what your guys' thoughts are as well.
Dave, I'm going to quote you. There is no such thing as unstructured data. But anyhow, I'll put that aside. That's just a wonderful, maybe a clickbait somewhere. But I'm sorry, Jesús, I really do want to hear what your thinking is on structure.
Yeah, absolutely. And well, I agree with, how rich, for example, the standards on the RDF stack are in the sense of you can really describe create an ontology that describes a domain with lots of rich primitives like domain, range, hierarchical, and all sorts of things. But it's important to understand that this is descriptive. It's not like, because constraints, I mean, especially those of us who have been working with databases of any kind, we think of constraints as constraints that are enforced on my data. So it's a way of limiting what I can store in my data. And if we start with relational, you can only add values to the columns that have defined in a table. I mean, if you want to add a new column, you will have to change your schema and go through a migration. So that's enforced. I mean, you cannot add a column a value to a column that doesn't exist. In the same way, if there's a primary key, you have to populate it and so on and so forth. So this is enforced and will limit, what you can store in your data. Now, when you define a schema with RDF schema or with OWL, that will not constrain you in any way. That's very important to understand. So these are descriptive schemas. Now, there are other standards that, again, there's loads of them in the RDF side and are more in this direction, right? Shackle would be one of them, but not all triple stores implement Shackle, because again, the idea is that you have another component that will validate, the data that you're persisting in your triple store according to these Shackle shapes. And sometimes I think that there's some misunderstanding, or in the sense that I can define a very rich ontology. I can even create a standard, and we have some of them in different domains. I mean, in the finance space, there's the FIBO ontology. There's the general schema.org, which is a very popular one that's used a lot. But the fact that you align with that will be determined by you applying best practices. But no triple store will enforce them on your data. That's very important to understand, because yes, I agree with you on that, Dave, in the sense that you can define it, but it will not constrain you and it will not force you to implement these kind of, I don't know if strictness is a word in your data. Whereas on the property graph side, which is, in general, it's true that there's not this kind of tradition of go defining an ontology before you start populating your graph. You effectively can define constraints, as in this property is required, and you will not be able to create a node without that property. I mean, again, this is implementation and depending on which vendor. But I think that's a very important point that sometimes creates confusion. So what is enforceable sort of constraints that limit the shape of your data, and what is kind of descriptive kind of semantics, which is what RDF, S, and OWL and those implement. Sorry, it's a bit long, but it's my regular rant on this topic.
That's actually a very good point. I mean, because you're right. There is a difference between what we would think about it like a traditional relational database schema, where your schemas strictly are implemented and enforced at essentially write time. That's true. That's true with both property graph and with relational databases, with RDF databases. As far as there may be one out there that works slightly differently. Like in general, they all basically allow you to kind of add whatever data you want to a thing. They may or may not enforce it. Constraints, at least as far as I'm aware, are always, or on any of the ones I'm aware of, are optional. As far as like, you don't have to add a uniqueness constraint or have to add this. So you can, even on a property graph side, you can go either way.
Exactly. That's exactly right. I mean, there's no notion of a primary key as a concept in RDFS or in OWL. I mean, the closest thing is like this notion of an inverse functional property, but that by no means is a constraint. It's like it's useful for inference. That's pretty much it. So that's
in RDF, the IRI is kind of a primary key because it's a universally unique representation.
Right. Okay. That would be that's valid. But let's say there's from that point of view that's a unique identifier. Perfect. But if you have let's say a unique property of any kind that you want to say, there no two nodes can have the same value for it, or if they do, they should be merged into one. There's the only way to do that is via inference. That's what I mean.
Okay. Yeah. I mean, property graphs have a similar thing. Every database implementation I know of has some sort of element ID, node ID, edge ID that's globally unique. So
why this contention between the two worlds? Because if you've ever been in a room with people that are arguing about the pros and cons, it can get quite heated. And I'm just very curious of whether this is a result of history, of culture, where one model took off more than the other, where it's more likely to be used. If it's more along cultural differences, and you really could do, something, everything you could do in one, you could do in the other, or if that's not quite right. What are both your thoughts on that?
Strictly speaking, it's true that anything that can be represented as triples can be represented in a property graph, and the other way around. With small adjustments. I mean, we could go into the traditional, thing of there's no easy way of adding attributes to relationships in RDF. Now there's ways to modeling workarounds now with the inclusion. I mean, with RDF star, that's less of a concern. But ultimately, you can represent the same information one way or the other. I mean, the question is whether it makes sense for your use case. What I was mentioning before. It's important to understand, the model, the way you represent the data, but then what's the database management system behind it, and what are the characteristics, and what's the type of workload that you're going to be, running. So these elements are the ones that can, make you go one or the other direction. Plus, of course, your I would say your past experience. I mean, these two models, as I was mentioning before, they work at different levels of abstraction, right? So it's true that, I mean, my impression is that the kind of the object model it's something that developers and data people are comfortable with, because people think in terms of object related to other things. Sometimes taking it down to the triple level requires some time, some kind of a practice, and it's a bit of a change. So it's anything that's represented as a property graph can be represented as RDF, but there's implications on how what your queries would look like, what your workloads would look like. But I would say that there's no reason why you could not go fully one or the other.
I mean, I agree. I mean, in the end, a graph is a graph, and you can represent either of these things as both. I also think, part of that, contention may or may not be the right word, but part of this also comes from the fact that people tend to lump together not only the type of data model, but also some of the standards, as we were kind of talking about. In RDF, they don't just talk about RDF. They usually, a lot of time when they're talking about RDF, they're also talking about RDFS or Shackle or OWL on top of it. Things like that, as well as the query languages. I mean, in Sparkle, you have RDF. In property graphs, you have soon to have GQL. Somebody implementing GQL, but as well as Cypher, OpenCypher, Gremlin, all of those things. Each of which add a different. It's not that at that point. It's not just the data structure, but it's also the semantics and the meaning and the behaviors of the query language that kind of get all lumped together into one. And there's certain things you can do better in different query languages than others, like everything else. There's pros and cons to both of them, to going either way or on any of those query languages. And I think that, I think a lot of times the contention is just a little overblown amongst things, because it may make a lot of sense for those of us that may be deep into this, where we understand all of these nuances. But I think it's also an area where if you're coming in, it's just an additional barrier to entry. In the end, I think, at least from my perspective, if people understand how to use a graph to solve their problem better, whether you use RDF, whether you use property graph, you can probably get it done with either one. It's just, what are you more comfortable in choosing to be able to answer that?
I like the thought, and I think Jesus, you brought this up as well. Earlier you were talking about the stack, and then Dave, you talking about it's like more than just the data model, and maybe that's an important point that I would want to call out if someone were taking a look at what they wanted to use, is like, let's look at the stack of tools, models, standards, whatever, integration points, and evaluate it as a stack as opposed to just the data model alone. I think it's a good call out and an important point. Dave, since you were just talking about uses, or actually all of us just talking about like use cases or uses and when you can use one or the other, I'd like to talk a little bit about like common use cases, and if there might be certain use cases that either of you feel are more appropriate for one kind of model and stack than another.
I mean, I would say, to the point of you can build it in either one. I think where I usually see people making a choice is, what is the makeup of the team and what are they most comfortable with working with? I would say generally, if I had to say, most developer teams tend to find just the property graph model a little more flexible, basically similar to what they're used to using from a relational database sort of paradigm. And we tend to find customers that we've worked with in the past, especially ones that tend to work in industries where like RDF data is very common, because one of the big strengths I don't know we've mentioned here is RDF data is built to be interoperable across systems. So there's a lot of public data sets available out there. So if you work in something like finance, I know Jesus mentioned that earlier, healthcare, there's actually a lot of chemical data. So manufacturing, a lot of those already have a lot of this data is already publicly available. There's a lot of shared ontologies around it, things like that. And those are the areas where we tend to see a lot of customers wanting to work, that are in those domains and have some of that expertise already in-house, because it's a very common thing. You choose something like an RDF data model or an RDF application to do it. It also comes down to what are the types of questions that you want to be able to answer between it, especially if you have questions that are dealing with paths, variable length paths, depths like that. Is an area where property graphs are better at doing it than most RDF data. Not because of the data model itself, but because of going back to kind of some of the statements about some of the additional layers and some of the behaviors that those implement on top of it. It's kind of one of the big areas where I tend to see customers choose a property graph versus an RDF data. But RDF data, especially if you want to do things like query into external data sources, one of the strengths of Sparkle, the query language for RDF, is that it has a built-in semantics for being able to query into these external data sources. So, like I said, it kind of comes down to some of those sorts of areas. But I'm interested to hear what you have to say on this, Jesus.
Yeah, and Jesus, I'm going to pre-ask a question. So definitely, I want to hear your thoughts on different use cases and strengths. But also, I want you to comment on something I've heard you say before, is the use of RDF as a transport layer, which I find interesting in the use of these things together. So, if you don't mind answering the first question, and then we get to the second one.
Sure, absolutely. No, I'll start. If you go to the to the W3C, well, I can't remember which of the models, the spec. I mean, when RDF is defined as a model for data exchange. So there's no statement saying that RDF should be stored in a triple store, because actually back in the day, RDF was actually embedded, as fragments in web pages. Then it was produced out of relational database. So RDF is really a model to serialize and exchange data. And if you describe it according to some standard models, then you will be enabling, like they were saying, interoperability. I mean, if we talk the same language, if I serialize my data according to the FIBO ontology, and you understand the FIBO ontology, you have a common language to interoperate. So that's brilliant. But all that, to me, that sounds like something on top of whatever your choice of data storages. It's true that, if you're managing triples, you probably have less friction if you put it on a triple store. Yeah, sounds natural. But at the same time, you have to pay the price of, a number of, you were talking about some of them, right? If you want to really leverage the structural nature of your data, and path would be one way, shapes, finding rings. I mean, one of the many use cases that we see on the property graph side is, fraud detection. Sometimes fraud detection is about detecting shapes in your data, like a ring in your data, like a chain of consecutive transactions that go over a number of accounts and terminate at the same originating one. Maybe that's a money laundering scheme of some sort. So, and from a data point of view, is finding a shape. And I would say that as of today, and I know that Sparkle is still evolving, there's no easy way of, for example, working with paths. Normally, these are extensions that different vendors have implemented. So you can say there is a path, but I cannot return the path, which is funny because you cannot work with it, right? So there's no construct in Sparkle for that. So I would say that the use cases that lean towards this structural analysis tend to be more, from my point of view, adequate for property graphs than RDF. RDF historically has been the sort of the standard in a way for knowledge bases, right? If you think of Wikipedia, not Wikipedia, DBpedia, which is the RDF, structured version of Wikipedia, and many others. Some of those that are, Wikidata. So these kind of collaborative knowledge bases where there's multiple contributors, multiple schemas, right? So this is where maybe the constraints around data integrity or transactionality were a bit less strong. So that's what historically RDF has been. But it's difficult to draw a line. I mean, ultimately it comes down, like they were saying, if you have a team that's expert in Cypher or in Sparkle, well, choosing one or the other is going to take you closer to your solution, and you will go down that route, right? So that's what I would say. And again, back to the point of RDF being this model for data exchange, we see that there's not an issue in storing your data in a property graph and then serializing and consuming public data stores, like you were saying, Dave. Like there's loads of public data sets. RDF, and you can ingest them in the property graph. You can present your property graph as RDF. So, in a way, I would say that we're pretty supportive of the RDF standards, with the exception, of course, of Sparkle on the property graph side.
In your experiences, do you see customers actually using both? And why do they do that? What do they gain from using the two very different approaches?
I mean, I would say I do see customers using that, and it usually comes down to why they choose one versus the other. It really comes down to kind of what that specific team feels most comfortable with, and how they want to be able to integrate that data with other data stores, either upstream or downstream from where they are today. I don't know. Jesus, what have you seen?
Yeah, I would say normally it's possible to have the two coexisting. I wouldn't say it's typically by design. It's a consequence of the social aspect, like they were saying. There is a community of users of RDF. There's a community of users, and it makes sense to have them, cooperate, right? But I don't think it's a natural choice to say, hey, we're gonna have the two, because you're artificially complicating your architecture for no reason. Now, if you have the two existing in your organization, it makes sense to try and build bridges and find ways to move data across and to have them integrating. So, but yes, I mean, to that point, we do have customers in Ep3 that use both, and that may mean, like I was saying before, offering presenting and exposing your data as RDF for consumers, even though they persisted in a property graph, or maybe they have deployments where triple stores exist and they move data across between one and the other. So that's, yeah, it's quite.
I mean, it's kind of interesting you bring that up, because I work on the Amazon Neptune team, and we support both RDF and Property Graph. One of the things we've actually been working on is what we call the One Graph initiative, which is to do exactly that, which is essentially to have one way of storing your data to allow you to interoperate over it over the exact same data stored in the exact same way, using either your normal RDF constructs, things like Sparkle, or be able to use your Property Graph constructs in languages like OpenCipher or Gremlin on top of that same data. So kind of help those customers that we have where they're doing both, or different groups want to use the same data in different ways.
To bring things up a little, I often feel like even myself, I've had a lot of misconceptions as I've gotten more familiar with the different approaches. What are the common misconceptions that you both are usually helping people understand?
I mean, I can go first on this one, and I would say I think the one of the common misconceptions I come across is the fact that if you choose a property graph or you choose an RDF graph, everything you do has to be that exact same. Everything you do from then on has to be part of that thing. Different use cases are going to be better in different, with the different strengths and weaknesses of the different data models and languages associated with it. So, in the end, it's all a graph. So as long as people, as long as you have a graph problem and a graph is the right tool to solve it, I wouldn't get too hung up and worried on is it RDF graph or is it property graph? Like there's a bit of an analysis paralysis, I think, that comes with having to make that choice so early on. My suggestion: try one out. You'll figure out pretty quickly whether this is something that is going to work for you or not. And I think the most important part is that you just kind of move on from this. I don't want to call it an arbitrary decision, but this complicated decision you have to make early on in your journey of working with graph data, to just try and figure out, really, in the end, is a graph going to solve your problem better than other uses or other technologies?
I would say that that's the most common misconception is that I was kind of introducing before, is this idea of, is it because I use RDF that I would magically have semantic data? And this kind of assumption, there's no magic in there. I mean, if you decide to, you can use a triple store as a graph database without any semantic features. If you decide to, to label your properties with your own terminology, and you don't create even an ontology for it, and you can perfectly do that. I mean, I'm not saying that would be good practice, but you can. I mean, there's no reason. Now, it's only when you start, either aligning with existing ontologies or even making the ontologies explicit in your data store, in your triple store, and then doing smart things with it, that it starts becoming something more than just data storage. So this idea of, because I'm going RDF or because ontologies exist, my data will be controlled, curated. None of that is true. You'll have to build it into it. I mean, all those are standards, are descriptive, and that's the one that I most frequently find. I mean, if people like, no, but I have an ontology, therefore that controls the shape. Oh, sorry, it's not going to happen. I mean, you can say that the relationship owns pet will connect me to my cat, but if I want to connect me through the owns pet to my armchair, that's going to work as well, and the property and the triple store will say nothing about it, will take it perfectly well. So it's how what's the exact meaning of an ontology, and the constraints in this type of models compared to the traditional constraints is the most common misconception out there. I mean, at least in my opinion, in my experience, basically.
So I just
tag a little bit on there, and to also say there's nothing that says you can't build all of a fully semantic layer on top of a property graph. There aren't necessarily as many standards and practices out there, and they're a little more implementation specific. But in the end, this kind of goes back to that, my layer analogy of these are just capabilities built on top of a data structure. You can build them with that.
So I have a question for both of you, because I actually heard somebody say the other day that the RDF is more naturally good at, or is better in general at, inference, because of some of this, the ontologies and some of the semantics that can like automatically get added. And so following on with what we just said, if somebody said, well, I've got to use RDF because I want to be able to do inference, what would your response be?
I mean, my response would be, first you have to understand, what inference means. And there's basically two ways of doing inference. I mean, you can write your own rules, and you can do that in every language. You can do it on relational data and property graph data. So you can write your own rules, and if you chain them, that will do inferencing, and that's one way. Or you can use ontologies. But if you use ontologies and you define some declarative semantics of your data, then you need an extra component, which is an inferencing engine. So that doesn't always come by default with triple stores, with RDF stores. So that's the first thing that you need to understand. And then also, if you want that to happen, you have to understand the semantics of things like OWL or RDFS, which is not trivial, I would say. In my experience, I spent a few years there, and I don't have numbers here, but I'll be curious to understand how often these are used. And I'd love to ask this question to our OntoText friends or the Stardog friends. How many people are using, are maybe using standard ontology or creating their own and running actual inference? Because it's not simple, and the kind of inference that these formalisms like OWL and RDFS provide are useful for certain and very specific use cases, and sometimes not exactly the ones that people expect. So I would say that it's not going to be an easy journey, right? And it's worth understanding what this exactly means, because there's still this misconception of some magic's going to happen just because I'm putting my data in RDF, and it's far from being real.
I would add maybe one thing to that is I would also call essentially any link prediction task basically an inference task. So that can be run, link prediction it's basically the same thing as inference. Yet again, we're back into nuances of the differences between them. But in the end, most databases allow for some sort of link prediction sort of functionality in there. So you can do them on both. You can, I have written many essentially query, Cipher or Gremlin query that is essentially a rules engine to create new connections or properties between things based on a standard set of rules. So I think this goes back to, in the case of RDF, there's a set of tools out there. You still have to know how to need to use them, but there are some I don't want to call them pre-built tools, but existing tools out there to be able to do it. Whereas in property graph, you end up having to do a little bit more at the application level, which has its pros and cons as well.
Yeah, no, you're right, and I typically tend to default to coming also from the RDF space to the kind of symbolic approach of reasoning and inferencing, which is not the only one. You're totally right. I mean, this idea of link prediction. I mean, inferencing. If you talk to any RDF people, inferencing is ontology based or rule based. That's why I said that there's only these two ways. It's true that it's not the only two ways, because link prediction can be seen as another way of inferencing, which is based on structure, which is less declarative, which is more machine learning based, and that's perfectly valid, and that's a very, very good point. Yeah, because sometimes we tend to kind of just narrow ourselves into these approach, which is not the only one.
So thinking about I'm thinking about people that are very early in their journey, trying to make a decision on which stack to use. So I'm gonna use that now. So it's not just a data model; it's a stack. But I've heard, just get started, just try it, see what works for you. I've heard, look at your team and maybe your integrations, your how your system needs to function holistically. Also consider, any standards that you might need to integrate with, financial, healthcare. And then look at use cases as well. And that's a kind of a big... If somebody isn't sure if their use case fits in, all things being equal, and they're not sure if their use case fits in one area or the other, we've talked a little bit about, maybe property graphs for very structural analysis. So where you're looking at patterns and shapes and data, and, RDF being very good for maybe your traditional knowledge structures, or there being a lot of standards for that. But how would let's say you're a product manager trying to build a product on top of with a graph of some sort. You've got team, you've got just try it, you've got look for standards, and where else do you go for help? Where do you try to if you're trying to figure out and parse these differences? I'll tell you, I've looked. I've done the Google searches, and there's just so much saying, all one way, all other way, and not as much out there that's good in actual evaluation. What kind of guidance would you give somebody who's trying to figure this out?
I think you've named most of the key criteria. I mean, I like to insist on separating, because that helps doing a proper analysis, the model from the database management system behind it. You have to understand, I mean, you're solving a problem ultimately. It's not like I'm going to build a graph. I mean, you're building a graph for a reason, right? You're trying to solve a problem, and you have some idea of the type of workload, of the type of, what's the shape of your data, what the kind of integrations, and some of that is not only, is it going to be triples, or is it going to be objects like nodes and relationships in a property graph? Is it what kind of, how is this platform going to make my life easier? How am I going to bring data in and out? How am I going to analyze it? How am I going to visualize it? Where am I going to deploy it? I mean, is it going to be in the cloud? Is it going to be self-hosted? Is it good? There's so many considerations that sometimes go beyond the pure choice of the level of abstraction of the model, but also the platform. So I think all these elements are important, and the skills in your team. I mean, what exists in your organization? How hard is it going to be to build a team around a particular technology? Look at that from that point of view as well. So I think all those are important aspects, and ultimately it's down to do your due diligence. Try it, build a prototype, a proof of concept, and make the right choice.
Dave, any other advice? I mean, I think I kind of agree with everything Jesús said there. It's really kind of, at least from what I've seen, the choice of whether you use RDF or property graph is probably the least important choice, as far as like all of the other things that he listed there, as far as how are you going to run it? How are you going to maintain it? What team skills do you have? Is this a cloud-based or an on-prem? All of those sorts of things. Do you have a graph problem? All of those sorts of things really kind of trump this one part of the decision. You're already, you should be pretty far down the stack of questions that you need to get answered before you kind of come into this sort of, I don't want to call it low level because it's a very important detail, but like, it's not the first place I would start.
Fair enough. So there's a lot of resources out there. I guess I have two last questions for both of you. One is what are you most excited about in 2024 around graphs in general? And it could be RDF, property graph specific, but graphs in general, what are you most excited about this year? And then if anybody wanted to follow you online or follow up with you, how should they find you? Where can they get more information and follow your work? So, Jesús, why don't you start since?
Okay, so I mean, the what's more exciting, and that's going to be probably an obvious one. I'm more curious than excited. Now we're seeing all the interest that's coming from the integration with large language models, generative AI, and I think it was one of the conversations that I was having with Dave at the Knowledge Graph conference. I would like to travel in time and see how much of that materializes into real value, real production deployment. So, but at this point, I'm curious. I'm excited about this, and I would like to see what comes out of all these kind of this combination of the knowledge graphs, graphs in general, and large language models. And where to follow me? I mean, you mentioned at the beginning, we're running. I mean, actually, we're now taking a kind of a mini break, but we run this monthly webcast that we call Going Meta, where we explore all sorts of things around RDF, property graphs. We experiment. And that's probably the best thing. And that's we publish all the content that we discuss and that we experiment with on GitHub, and that's the best way to engage with us. And that's what I would recommend. So these are my two answers.
Awesome. And Dave, how about you?
I mean, I think much along what excites me most is much along the lines of what Jesús said. I think to me the most interesting part here is what I see the biggest win of working with graphs and large language models and generative AI in general is it's bringing a whole new set of people to the graph world that may or may not have ever been there before. So I'm interested to see whether it's with generative AI and large language models or just other use cases, what they're able to, what people are able to accomplish with this new technology that they've discovered as far as, graphs and knowledge graphs go. And as far as getting in contact, being able to follow me, I would suggest looking at my LinkedIn profile is probably the best. That's where I tend to repost most of the things I'm working on, things I find interesting, things of that nature.
Again, thank you very much, and look forward to having you again on the GraphGeeks podcast.
Yeah, that's great.